A 2-kilogram ball on a 1.5 meter string swings in a vertical circle. At the bottom of the swing, the ball moves at a velocity of 6 meters per second. What is the tension in the string? Take acceleration due to gravity to be 10 meters per second squared. At the bottom of the swing, we are going to find the tension in this string. So we first need to draw a free body diagram for this ball. A free body diagram is a simplified model where we use a dot to represent the ball, and also we use arrows to show all the forces acting on the ball. And in this bottom position, the only two forces acting on this ball are 1, force of gravity, and 2, the tension force. But let us specify our coordinates such that we can track the direction of each force vector. So since we are dealing with this vertical forces at this point, we are going to use the y-axis such that any force pointing upwards is going to be positive and any force pointing downwards is going to be negative. In this case, we have vertically downward the weight of the ball pointing downward, so we have mg, and also upward is going to be a tension developed in the string, so that tension we call it T. Now we know that the radius of this circle is going to be the length from the center of the swing to the center of the ball, so that is the radius. So this is all we have vertically acting on this ball. So if we apply Newton's second law, the net force acting on this ball at this point, which is in the vertical direction, is what is the centripetal force. And we know centripetal force to be the mass times the velocity squared divided by the radius of the circle or the circular path. So in the vertical direction, we have the tension which is pointing upwards, so positive tension, all right, minus the weight pointing downward, which is minus mg, and that is equal to the centripetal force, which is the mass of the ball times the centripetal acceleration. And remember, the centripetal acceleration points upwards towards the center of the circle. If you look at here, it points towards the center of the circle here, so it's going to be upwards in this case. So that is why we have mv squared over r. So to solve for the tension, we isolate the tension. So using this equation, we can add mg to both sides. So it is going to be plus mg, and then on this side, we are going to have plus mg. So that gives us minus mg plus mg cancels out, and then that isolates the tension, and we are left with the tension to be T is equal to mv squared over r, and then plus mg. Okay, so plus mg. Now we can plug in the values. So we are going to do the tension in the string at the bottom location is going to be the mass of the ball, which is 2 kilograms, times the velocity of the ball at that point, 6 meters per second squared, divided by the radius, which is 1.5 meters, plus mg, which is again 2 times 10, which is acceleration due to gravity. So if we evaluate all of this, we get the tension to be 68 newtons. And this is the tension in the string at the bottom location when this ball is undergoing a circular motion with a velocity of 6 meters per second. I hope you enjoyed this video. Like, share, and also follow for more of such videos. And until then, I'll see you on the next one. Bye-bye.